For number one here, these are both order of operation problems. For the first one, we have enclosing symbols here. We have parentheses. Left to right, this is our first one, and its other end is all the way down here. Well, inside there, we have another set of parentheses, so we're going to focus inside of those. In that set of parentheses, no other enclosing symbols. We do have an exponent. 4 squared, which is 16. So still focusing inside that inner set of parentheses. No more exponents. All that's left is multiplication and division. We're going to go left to right. 3 times 16 is 48. And of course, we rewrite the rest of the problem. And now all that's left inside that parentheses is the 48 divided by 6, which would be 8. I'm going to get rid of the parentheses. Remember, I checked to make sure the parentheses isn't doing anything else. And it's not. It's not signifying multiplication or anything like that. So I don't have to do anything other than remove the parentheses at this point. And of course, rewrite the rest of the problem. Now I'm back out to that larger set of parentheses. In there, there's no other enclosing symbols. There's no exponents. We do have multiplication and division, so I'm going to go left to right. 24 divided by 8 is 3. And next we have the 15 divided by 5, which is also 3. Now all that's left inside of that set of parentheses is addition and subtraction. So again, we'll go left to right. 3 plus 3, which is 6. And finally, the last step is 6 minus 3, which is 3. Now, once again, we've reduced the parentheses to a single number. I'm going to remove the parentheses. In this case, however, the parentheses is doing another job. It is signaling multiplication. So I have to put that multiplication in when I remove that parentheses. Now we have the multiplication. 3 times 3 is 9. And 7 plus 9 is 16. Show of hands, how many of you had 16 for that one? How many of you would have if I gave you more time? Any questions on how we got to that? That one's right on the edge of what I would ever expect you to know. Probably the most difficult I'd ever expect you to do on a test or quiz. But again, we should be able to follow step by step and get to those answers. Anybody need me to go back down to the bottom so they can finish copying down the steps? Good? Okay. For the second one here, this is a fraction bar across here, which means we have to do everything on top first, then everything on bottom, and then we divide out those results. So on top, I have 7 times 5 plus 25 divided by 5 squared. Well, first thing I have there is an exponent, 5 squared, which is 25. Now I have multiplication and division. I'm going to go left to right. 7 times 5 is 35. Then we have the 25 divided by 25, which is 1. And finally, 35 plus 1 is just 36. So the top of that fraction comes out to be 36. Let's do the bottom of the fraction. We have two exponents, so we're going to go left to right. The square root of 4 is 2. Now there's that 29 in front of it. That square root symbol was also signaling multiplication. Then we have the 7 squared, which is 49. Next we have multiplication. 29 times 2 is 58. 58 minus 49 is 9. 36 divided by 9 is 4. So the answer to that one is 4. Any questions there? Okay, well, today we're going to shift gears slightly. Not working with just numbers, we're going to work kind of with formulas. But I kind of want to show you where each of these formulas come from. So to do that, we need to talk a little bit about some basic geometry. Geometry, as you know, is the studies of shapes and distances and relationships. The basis of geometry, just like we said that everything in math comes from that definition of a number, in the geometry portion of math, everything comes from this structure right here. It's called a point. It is simply a location. It has 0 dimensions. A dimension can be defined a lot of ways. Some define it as a measurable direction. Others define it as a direction of movement or a unique direction of movement. And others define it as degrees of freedom. In other words, we're free to move in different directions. They all kind of mean the same thing. Now I can take that point and I can move it drag it in a single direction. And what I've created here, a lot of people would refer to that as a line. It's technically a line segment. Because technically, a line continues forever in both directions. Well, in practical applications, that's not very useful. We are into finite or measurable things in applications. So a line for us is really going to be that line segment. The length of that line segment is equal to the distance that we move the point. This is now 1 dimension. Because it was created by movement in a single direction. And if I were on it, I could move a single direction. I could move this way or this way. Well, you might say, well, that's 2 directions. No, it's not. It's 1 direction. It's the positive and the negative of that direction, but it's still only 1 direction. Well, next, I can take that segment and I can move it in a second direction. Now, it has to be a second unique direction, which means if I move it like this, I'm still moving it partially in the same direction as I moved the original point. So the only unique direction is to go like this. That movement is what we call perpendicular. In other words, at a right angle to the original movement. In other words, it's a totally unique direction. No component of it is in the same direction as the original movement. Well, what we've created here, most of you know this is a rectangle. But for our purposes, we're concerned about the fact that it is an area. This is the first point in this whole process where we're actually able to cover something up. The line over here can't cover anything up because it's narrow. It's infinitely narrow. It has no width to it. A rectangle now can be used to cover. That's the definition of area. The size of which it can cover is defined by that original length on, again, a distance moved. That distance moved is often referred to as a width. This rectangle now has two dimensions because if I'm in that rectangle, I can move in two unique directions without moving outside the rectangle. I can move this way or this way, but I can also move up or down. Now, some might ask, well, what if I move this way? Isn't that a third direction? No, it isn't really. It's a direction that contains components of those other two. Some of it's moving this way, some of it's moving that way. I made that really small so it's hard to see. Sorry about that. But moving at that angle, we're not going to get into the whole vector analysis anyway, but moving at an angle just contains parts horizontal and parts of a vertical movement. It's still two dimensions, two unique directions. Think of it this way, as it was created in moving that point in two different directions. So the area, the size of that area, like we said, depends on that original length of the segment and that distance that we move, the width. And that is our first formula for the area of a rectangle. Area is equal to length times width. We usually abbreviate that using just capital A for area, little l for length, and little w for width. So if I have a rectangle here, now technically to signify that's a rectangle, I should show you that that corner is a right angle. I should show you technically that all the corners are right angles. But in our drawings, even in the textbook, if it looks like it's a right angle, if it's not labeled otherwise, you can assume that it's a square corner or a right angle. So the area of this will be a length of 11 inches times a width of 6 inches. We multiply the counts. 11 times 6 is 66. But remember, we also multiply the names. Inches times inches is inches squared, or square inches. So that area is 66 square inches. So in your notes, give me a quick area for this. 8 feet times 12 feet. Find that area quickly. Okay, so it doesn't matter whether you use 8 feet times 12 feet or 12 feet times 8 feet. It really does not matter what you consider to be the length or the width. It works out to be the exact same answer. 8 times 12 is 96. Feet times feet is feet squared, or square feet. Now there's a lot of cool things you can do with this. This rectangle can be cut in half. But not the way you'd think. We can cut it like this as a right triangle. This is still 8 feet here, and this is still 12 feet here. You can see that this triangle is exactly half of the rectangle we had up here. In fact, when we're looking at finding the area of a triangle, we actually look at the area of a related rectangle. The related rectangle, of course, would be just this one here. The area of that related rectangle is 12 feet times 8 feet. Since the triangle is exactly half of that, we either multiply by 1/2 or divide by 2. So that related triangle, the triangle is 48 square feet, or half of that related rectangle. What if it's not a right triangle? What if it's something like this? Well, if I know that side is 12 feet, I need to use a related rectangle. A related rectangle would be like this. So I need to know what the height or the width is of that related rectangle. Well, the dimension on my triangle that gives me the width of that rectangle would be here. From this corner that's the furthest away from the 12 feet down to the 12 feet at a right angle. That dimension is called an altitude, or often just referred to as the height of the triangle. Well, if that is 8 feet, you'll notice my related rectangle in green there is still 12 by 8. So the area of that rectangle is still 12 feet by 8 feet. So the area of the triangle is 12 feet by 8 feet divided by 2, or still 48 square feet. Not all of our shapes are that nice and neatly cut out. In fact, one of the skills I find that students struggle with more and more each year is related to this. So again, assume all of these corners are square corners, even though my drawing kind of sucks. Let's say that this is 20 inches here. We'll call that 18 inches, 12 inches, and 32 inches. If I ask you to find the area of this shape, we have two options. Option 1, divide it into smaller pieces and add them up. How can I do that? Well, there's two ways I could divide this up. I could cut it like this and do it as two rectangles like that. Or I could cut it across here and do it as two rectangles like that. Doesn't really matter which I do. I'm going to go ahead and just cut it right here. So I have 1, 2 rectangles. Well, to find the area of those rectangles, I have to know these missing dimensions. This one here in green and this one here in purple. To find those missing dimensions, of course, I'm going to use the ones I have. Let's look at the green dimension first. That dimension goes vertically, up and down. To find its length, I can only use other dimensions that go vertically. So that means the 20 and the 12. Now I need to double check to make sure that those actually cover the same distance, and they do. The bottom of the total length is down here, the top is up here. I notice this missing dimension and my 12 make that length together, and the 20 makes it all by itself. So that's telling me that this missing dimension here adds with the 12 to make 20. In other words, 20 minus 12 equals 8. That is this missing dimension, 8 inches. The purple dimension there, that was a poor choice of color. Let me change that color there. I'll write this is 20 minus 12 so I don't confuse you. Equals 8, so this is 8 inches. My purple dimension, it can only combine with other dimensions that are horizontal. So the 18 here and the 32. Again, I see that they go from this far edge to this far edge. The 32 does it all by itself. The 18 combined with that missing dimension makes that length. So the 18 plus that dimension equals 32, or again, going backwards, 32 minus 18 equals 14. This dimension is 14 inches. Now I can find those areas. Area 1 here is a big rectangle, 20 by 18 or 18 by 20. 20 inches by 18 inches, which is 360 inches squared. Shape 2 is 12 by 14 or 14 by 12, however you want to put it, or 168 inches squared, which adds up to 528 inches squared is the total area of that shape. Now I said there were two options. Option 2 is to fill in and subtract. What does that mean? Well, that means what I would do is I would fill this in to make a complete rectangle here. That complete rectangle has dimensions of 32 by 20. "32 inches times 20 inches is 640 square inches. And then from that, I have to subtract off this piece here that's missing. That piece, we found the dimensions, is 14 by 8. That's 112 square inches. By subtracting, I get 528 inches squared. Notice I get the exact same area either way. And in this problem, it's about the same amount of work either way. Really isn't any different whichever way we do it. There will be some problems that'll be easier to do one way than the other. For example, we might have a problem like this. Try that again. There. Obviously, my drawings are not done to scale, by the way. Okay, that should be all we need to know for this one. This one, if we try to chop it into smaller pieces, it gets really ugly. I suppose we could cut it here and here and here. We get 4 different pieces that we have to find. This is one that I would say is probably easier to fill it in, find the big area, and then subtract out the missing pieces. Well, to do this, the first thing I need to know is what this overall length is here. Well, I can find it by adding the 3, the 5, and the 12, all add up to that overall length. 3 plus 5 plus 12 makes 20 inches of length. So the overall area of this, the big area, is 20 inches by 14 inches, or 180 inches squared. Now from that, I have to subtract this smaller piece here. That's 6 inches by 5 inches, or 30 square inches. That puts me at 250 inches squared. And I also have to subtract this piece. Well, I know it's 6 inches, but I need to know this dimension. Well, I've got my 14 and my 10 are the other dimensions that go in that direction. Now I'm making an assumption. I made the assumption that this is also 6 inches, so that these two pieces are lined up. But anyway, the 10 plus that piece makes the 14. So 14 minus 10 makes that 4 inches. So that piece there is 6 inches by 4 inches. or another 24 square inches that we have to subtract off, giving us 226 square inches as our total area of that. Like I said, cutting that one into pieces and trying to add it up would be difficult. Now, if you're struggling to figure out how to cut these into pieces, a strategy that I recommend is to just pick a direction, vertical or horizontal, doesn't matter which. This one, all of the main features seem to be vertical, so let's divide it vertically like this. I'm going to drop a line there, there, and there. I have now cut this into 4 sections, all rectangles. This first section is a 3 by 14. So 14 inches by 3 inches makes 42 square inches. This second section here, I got to do a little bit of work. This piece here is going to be 14 minus 6, or 8 inches. Because that piece and the 8 inches has to add up to the 14. So this here, the second piece, is 8 by 5. Or 40 square inches. Come on. The third piece here is the full height of 14 by, we need to know this distance. Well, this is 12, and we subtract out, this is 6. So this piece is also 6. That's going to be 14 by 6 for that third piece. (84 inches squared). And this last piece is just 6 by 10. Or 60 inches squared. If I add those up, once again, they add up to 226 square inches. Now, part of it depends on how your mind works, how your brain sees things. To me, this one was a lot easier to do by filling in those corners, finding the big shape, and then subtracting out the missing pieces. However, some of you may not like that. Your brain doesn't function that way. It may be easier to divide it up like I just did here the second time. You should get the same answer either way. Just whatever works easiest with your way of thinking. We might have one like this. And we're going to assume this one's symmetrical from one side to the next. Find the area of this one. This one, again, is one that could go either way. I could fill in these rectangles here, find the big area, and then subtract those little pieces out. Or I could cut it into small pieces and add them up. It's going to be about the same amount of work either way. Let's do the cutting it into smaller pieces first this time. So I'll cut it there and there. The major features seem to be horizontal, so I'm going to cut it horizontally. So I have 1, 2, and 3 pieces to do here. Piece 1 is 3 by 14. 15 inches times 3 inches. 42 inches squared. Piece 2 there is 7 by, I need this dimension here. Well, I said assume it's symmetrical, so if this is 5 and this is 5, I have 14 minus 5, and minus another 5 makes that 4 inches. That piece there is 4 inches by 7 inches. 28 inches squared. And finally, piece 3, well, this is still 14 inches down here because pieces lined up. This is going to be 8 inches by 14. 8 times 14 is 112. So that adds up to 182 square inches for that total area. Well, if I did it the other way, if I made it a full rectangle like this and subtracted out, well, this is 14 here. I have to find this dimension. Well, that's just going to be 3 plus 7 plus 8, which of course is 18 inches. So that would be 18 inches by 14 inches, which is, what is that, 252 inches squared. It's been a slow morning, I'm double checking. There we go. It is 252 inches squared. And then I have to subtract out those two missing pieces. Well, this piece here is 5 by 7. 35 square inches. I have to subtract it, and I have to subtract it again. This one's the same size. So subtracting 35 twice is subtracting 70. That's 182 square inches. So again, in this one, it was about the same amount of work either way. So it depends on what way your brain sees those. Let's talk about basic volume. So we have moved in our two directions, and we've created a rectangle. So what I've drawn here, pretend this is just a rectangle, but you're looking at it from up above and at an angle so that it looks like it's kind of strange like that. If I take that rectangle, just like I took the line segment and moved it in a separate direction, if I take this rectangle and move it in a separate direction, I have now created a box. This is the first time, we said the rectangle was the first shape capable of covering. This is the first shape that is capable of containing. And the amount that it contains is called a volume. The size of this box is dependent on the area of that original shape. That original shape is called a base because it is the shape that is moved to create the whole object. It's the shape that the object's based off of. And again, this distance moved. For a solid object like this, that distance moved is often referred to as a height. So the definition of volume is the area of a base times a height. So for this over here, let's say that this base, that rectangle we were based off of, the base is sometimes on the bottom, but not always. Let's say that this was 12 inches by 10 inches, and this height is going to be 8 inches. The area of the base, A with the little b there, is 12 inches by 10 inches. Or 120 inches squared. So the volume is the area of that base, 120 inches squared, times that height of 8 inches. Giving us 960. Well, inches squared times inches is inches cubed, or cubic inches. Now, many of you have seen volumes defined as simply length times width times height. Well, and that's really what we just did here. The length times width is the area of the base. But the reason I define it this way is because we don't always have a simple box. We might have a shape something like this. I do this one here. So let's say that this is, I'll change color to label my dimensions here so it's a little clearer. let's call this here 4 inches. Up here, we'll call this 16 inches. 6 inches here and 12 inches here. And we'll call this height of 5 inches. So here, this is not a simple box. I can't do length times width times height because there is no length and width. But I can realize that this shape here is the base of this volume. Why do I say that's the base? Because I could take that and I could slide it up and down in that object, and it would be the same shape. It would slide in and out through that object. In other words, if I looked at this object at any different layer, I could stack up that shape to make the whole object. So I find the area of that base. I have to do it in sections. I'm going to cut it across here. This piece is 16 by 6. Which makes that 96 inches squared. This second piece here, well, I got to do a little work. This is 12 here, from here, and this is 4. Actually, I don't have to do much work there. 12 inches by 4 inches, 48 inches squared, giving me a total area of that base of 144 square inches. Now my volume is simply the area of that base times a height. This is my height. That's the distance from one base to the other. I can think of the bottom as also being the base. 5 inches is the distance between where it would start and stop if I moved it through the object. I realize that was kind of cloudy, but the bottom here is the same shape as what we just found. The distance between those two shapes is that height. So 144 square inches times that 5 inches of height is, oh, what is that? We're just going to do it. 720. Okay, 720. Come on. 720 inches cubed is my volume. So being able to find the area of that base and then just multiplying by the height drastically simplifies this. Otherwise, we'd have to try to cut this shape up into different boxes, find each of the individual boxes, and add them together, which works, but it's a lot more time and a lot more effort. Let's look at a shape something like this. So I got to label some dimensions in here. I'll call that 12 inches. This here will be 8 inches, 6 inches, inches here, so 6 inches here, and 6 inches here. And we'll make this 5 inches again. Now we said the base is often the bottom, but not always. Here, the base of this shape is this front side. The reason that's the base is if I think about it, that's the piece that I could slide it through and it would match up with the other side as well. That's my base. So to find the area of that base, I have to cut it into pieces. So I'm going to cut it into 3 pieces. This first piece here is 12 by 6. (72 inches squared). My second piece here, well, this is 10 inches. If this is 8, this has to be 4 because they have to add up to the 12. So that piece is 4 by 10. Or 40 inches squared. And finally, this third piece, this is 6 here, and this is 6 here. So that's just 6 by 6. 36 inches squared. Well, that all adds up to an area of a base of, what is that, 148 square inches. Now to get my volume, I take the area of that base, the 148 square inches, and I multiply by the distance from one to the other. Remember, we said it moved back over to here. Well, the distance between them is this 5 inches. So times 5 inches, is that 740? Inches cubed is that volume. Any questions there? Okay, good. Now a reminder, you do have that quiz 1 from yesterday. Make sure that is submitted by noon today. Is there anything on that you had questions on that you weren't sure how to figure out that you wanted me to go over?
There was one problem on mine where I was confused with the labels on them.
Okay.
It was a number like 9. It was talking about feed and proteins and vitamins, and then it talked about how much vitamins and feed I needed, but I didn't know if I needed to pull some out or if I needed to keep them all together, you know.
Oh, no, you keep them all together. Just add them up.
Okay. Is there any way I could redo that one or no? After
Just send me an email saying that you wanted to change your answer on that question.
Sounds good. Thank you.
You bet. Okay, so then the new homework on the stuff we did today is in your book, page 17 through 19, 1 through 39.
I'm sorry to interrupt.
Yeah, go ahead.
I posted my answers in the comments. Is that all right?
Yep, that works just fine.
Okay. Thank you.
You bet. So anyway, our new homework in the book, page 17 through 19, problems 1 through 39, the odds. As always, again, if the first couple are pretty simple, feel free to skip ahead to the more difficult ones. These are the ones that people tend to make the most mistakes on when we get to quizzes and tests. So make sure you look at least look at the more complex ones with the different shapes and cutouts like we did the last couple of examples here. Anybody have any questions? Okay, well with that, you guys if you want to take a few minutes to work, I'll be in here for the next 7 minutes. Otherwise, if you want to start cleaning up, wiping down your tables, I understand that as well.